Welcome to this quick JavaFX tutorial. Today, we're creating a stunning particle animation in less than 100 lines of code. Fast, simple, and perfect for beginners. Let's jump right in. Before we start building our mini particles animation, let's take a moment to set up everything we need from JavaFX. We start with JavaFX application. This is the backbone of every JavaFX program. It gives us the structure to launch our app and define what happens when the window opens. Next, we bring in the scene and group classes from the JavaFX scene package. The scene is essentially the world or canvas where everything gets displayed, and the group allows us to organize visual elements inside that scene. Then, we import the Canvas and GraphicsContext classes. These two are extremely important for our particle effect, because instead of placing shapes one by one as nodes, the canvas lets us draw directly on a 2D surface, similar to painting on a blank sheet. GraphicsContext acts like our digital paintbrush, allowing us to draw circles, lines, and even create smooth fading trails. We also include the color class, which we'll use to generate bright, glowing particles. JavaFX supports HSB colors, so we can create dynamic, colorful animations with ease. Next, we import the stage class, which represents the window that appears on screen when our program runs. This is where our canvas, our particles, and everything else will actually be displayed. Now Mini Particles class extend it from the application class. Once you do that, your IDE will ask you to override the start method. Go ahead and generate the start function. This is where our entire animation will be created and displayed. Next, we create a small inner class named P, which represents a single particle. Inside it, we define variables for the particle's position, its velocity, its radius, and even its color. These values will allow each particle to move independently, bounce around the screen, and draw with unique visual effects. Every particle you see in the animation will be an instance of this class. Now let's take a closer look at the constructor of our particle class, because this is where each particle gets its personality and behavior. The constructor takes two parameters, W and H, which represent the width and height of our canvas. We use these values to make sure every particle starts somewhere within the visible area. The first thing we do is set the initial x and y positions. We assign x equals math.randomW, and the same idea for y. This means every particle spawns at a completely random spot, from the left edge all the way to the right, and from the top to the bottom. This randomness helps create a natural and scattered look, instead of having all particles start from the same point. Next, we define the particle's movement by assigning values to vx and y, which stand for velocity in the x and y directions. Here, we give each particle vx equals -1 plus math.random2, and we do the same with y. This formula is clever because it generates a value between -1 and +1. A negative value means the particle moves left or up, and a +1 means it moves right or down. By giving each particle slightly different speeds and directions, the animation becomes much more dynamic and interesting. We then assign a radius using r equals 1 plus math.random3. This gives each particle a size somewhere between 1 and 4 pixels. Some particles appear tiny and subtle, while others are just large enough to stand out a bit more. This variation adds depth and texture to the animation, helping it look more like a living particle field rather than a set of identical dots. Finally, we set the particle's color. We use color.hsb math.random360, 1, 1, 0.9. This is a really powerful trick that makes our animation visually rich. Now let's take a look at the update method, which is responsible for moving each particle and keeping it inside the screen. The first thing this method does is adjust the particle's position by adding its velocity to the x and y values. So every frame, the particle shifts slightly in the direction it was assigned earlier, creating smooth motion across the canvas. Next, we check whether the particle has reached the left or right edge of the screen. If the x position goes below 0 or beyond the width, we simply reverse the horizontal velocity. This creates a bouncing effect, making the particle instantly turn and move in the opposite direction. We apply the same idea for the y-axis. If the particle touches the top or bottom edge, we flip the vertical velocity. This keeps the particle confined within the canvas and prevents it from disappearing off-screen. Overall, this update method ensures each particle moves naturally, reacts to boundaries, and stays in constant motion throughout the entire animation. Now let's set up the main drawing surface for our animation. We start by creating a canvas with a width of 800 and a height of 500. This canvas is basically our digital painting area, it's where all the particles will be drawn every single frame. Next, we get the graphics context from the canvas. Think of the graphics context as the toolset that lets us actually draw things. With it, we can fill shapes, draw circles, change colors, clear the screen, and create all the visual effects that bring the animation to life. Then we place the canvas inside a group. A group is simply a container that can hold one or more visual elements, and in this case, our canvas is the only one we need. Finally, we create a scene using that group and set the scene size to match the canvas. We also give the scene a black background, which helps our colorful particles stand out beautifully. With this setup complete, we now have the main space where our animation will appear. Next, we set the number of particles to 220, and create an array to store them. This array will hold every particle object we generate, letting us update and draw all of them inside the animation loop. Then we start a loop that runs from 0 up to the number of particles. This loop will allow us to create each particle one by one and place it into the array. Inside the loop, we create a new particle by calling the P constructor, passing in the canvas width and height. This makes sure every particle starts at a random position within the visible area of the screen. This is the engine that drives our particle system and makes everything on the screen come alive. We start by creating a new animation timer, and inside it we override the handle method. This method runs automatically every frame, usually around 60 times per second, and it's where all the updating and drawing happens. Inside the handle method, the first thing we do is read the current width and height of the canvas. We store those values in W and H. This is useful because if the window is resized or scaled, the particles will still know the boundaries they need to stay within. Next, we set the fill color to a translucent black using color.RGB, 0, 0, 0, 0.15. This line is extremely important for creating the smooth trailing effect behind the particles. Now we come to one of the most important parts of this entire project, the animation timer. This is the engine that drives our particle system and makes everything on the screen come alive. We start by creating a new animation timer, and inside it we override the handle method. This method runs automatically every frame, usually around 60 times per second, and it's where all the updating and drawing happens. Inside the handle method, the first thing we do is read the current width and height of the canvas. We store those values in W and H. This is useful because if the window is resized or scaled, the particles will still know the boundaries they need to stay within. Next, we set the fill color to a translucent black using color.RGB, 0, 0, 0, 0.15. This line is extremely important for creating the smooth trailing effect behind the particles. Instead of clearing the screen completely, we draw a slightly transparent black rectangle over the entire canvas. This gently fades the previous frame, allowing moving particles to leave beautiful trails as they glide across the screen. Next, we bind the canvas width and height to the scene's width and height. This means that whenever the window is resized, the canvas will automatically adjust with it. We won't need to manually update the dimensions, JavaFX keeps them perfectly synchronized. This makes the animation flexible and responsive, ensuring the particles always fill the entire visible area, no matter how the user resizes the window. Finally, we set the title of the window to Mini JavaFX Particles Demo so users know what the program is showing. Then we attach our scene to the stage, which places the canvas and all of our visual elements inside the window. And with stage.show, we make the window appear on the screen, officially launching our particle animation. And finally, in the main method, we simply call launch. This tells JavaFX to start the application, open the window, and run everything we set up in the class. And that's it, your mini particles animation is now complete. Go ahead and run the project to see your colorful particles bouncing and glowing in real time. If you enjoyed this tutorial, feel free to like, subscribe, and check out my other JavaFX animations. Thanks for watching, and I'll see you in the next one.